going over some complex rational expressions. This is basically back to just working with fractions, applying all the rules that you've always learned about fractions. In your book, it's section 10-10, and we're going to be going over problem number 24. So here's the problem. What I want you to do is break it out and think of it not in this format, but actually as a divided by sign, and then we can get rid of this line in front. Does that make sense to everybody so far? Think about it. A fraction over a fraction is also called a division bar. So we're taking our first grouping of fractions, it's divided by the grouping of fractions beneath it. Now, anytime we work with fractions, adding or subtracting back to basic fraction is that you have to find a common denominator. So our lowest common denominator, and we're just going to be dealing with this section first. And that's going to be x times the sum of x plus 2. So let's go back to it. So we have our x plus 1 over x plus 2. What do I have to multiply the denominator x plus 2 by to get our LCD of x times the sum of x plus 2? Well, the difference between the two is x. So you multiply top and bottom by x. Why? Because x over x is the equivalent of 1. So we're making an equivalent fraction just with the denominator that we need. Let's do it to the second part. I've got 1 over x. What is missing from our LCD? It is the x plus 2 over the x plus 2. Okay? So now that we've got that, let's just combine this, make this a little easier. That is x times the sum of x plus 1 plus x plus 2 all over the denominator of x times x plus 2. Now let's look at our second side and do the exact same thing. Our lowest common denominator here is going to be x squared times x plus 2, isn't it? So once again, let me draw lines so we don't get confused with where we are. We're going to take our x over x plus 2, and what do we have to multiply that by to get the denominator, our common denominator? That would be x squared over x squared. Then we take our 1 over x squared, and we're going to have to multiply that times x plus 2 times the sum of x plus 2. Working this out, this gives us a denominator of x squared times x plus 2. And our numerator is going to be x times x squared is x to the third plus x plus 2. So now let's look at our problem from this point on. So now, it's just to divide it right here. Let me rewrite it. So I've got x times the sum of x plus 1 plus x plus 2 over x times the sum of x plus 2 divided by x to the third plus x plus 2 over x squared times the sum of x plus 2. Now we know, back to basic fractions, we're going to change it from a division problem to a multiplication problem by switching that second fraction and changing to multiplication. Copy down the left-hand side. Okay, now it becomes multiplication, and we're going to flip it. Okay, now that we have a multiplication problem, now you look at what you can cross-cancel. Remember, it can't be anything that's added to it, it has to be multiplied by it. So what we can cross-cancel is this x plus 2 and that x plus 2, can't we? And then this x, going across, this can be reduced to, instead of x squared, to just x, correct? So now let's look at what we have. So we're going to take it, and that's going to give us on the outside, I've got this x times that x, correct? So that is going to give me x squared times x plus 1 plus x plus 2. Don't get confused with what you're adding, what you're multiplying. All over x to the third plus x plus 2. So now let's look. We're almost done. Now we have this addition part. So let's take what we're adding inside these two. So our x squared stays on the outside, and then x plus x is 2x, correct? And then I've got plus 3. Okay? All over x to the third plus x plus 2. So let's look at our numerator. We can write that a whole lot better, can't we? Or we could just leave it like that. And there's your final answer at this point in the game. Let's look at one more. You were having trouble with the letters instead of numbers. So I've got a over b plus c over d. All of that divided by b over a plus d over c. Now, the book kind of got you confused because you were doing the lowest common denominator for all 4 fractions. So instead of that, let's just break it up fraction by fraction. We know that this is going to be the same as, I can't move that over. So it's going to be the same as a over b plus c over d divided by b over a plus d over c. So let's work with this part of the fraction first. So our common denominator is going to be BD, isn't it? So I'm going to take A over B, and in order to get my lowest common denominator of BD, I need to multiply both sides by numerator and denominator by D, don't I? Plus C over D, and I'm going to need to multiply that by B over B. Now I have them with the common denominator, so I've got AD plus CB both over BD. And when we're doing these, it's easiest to keep them in alphabetical order as we go. Okay, divided by, let's take this one, our LCM, or LCD, is going to be AC, isn't it? So I've got B over A, and I have to multiply that by C over C, plus D over C, what's missing from my denominator is A. So this becomes BC plus, let's do AD to keep them alphabetical order. D times A is the same as A times D, all over AC. Now that we have it simplified to a fraction divided by a fraction, this is the point where you'll take your second fraction and you'll flip it. So we have AD plus CB over BD multiplied by AC over BC plus AD. Look at this first one. I didn't keep it in alphabetical order, did I? CD is the same as BC. Just easier to work with. So now that we're multiplying, look at what we can cross-cancel. Now, this whole term can be cross-canceled with that whole term, can't it? So we'll just cross-cancel those. So our answer becomes AC over BD. All you have to remember is to keep all the rules that you've done with fractions. And although these are more steps, you've done everything before, you're just applying prior knowledge into a new context.